Hello, I am Wissam Ali-Ahmad with the Global Strategic Alliances team at Splunk. Welcome to this demo of IT troubleshooting with Splunk and Cisco UCS. Splunk provides an open, fully integrated platform. That means you can collect, index, analyze, report, and predict on machine-generated data from a single product. It's enterprise-ready with high availability and disaster recovery features, role-based access control, and scales to index petabytes of data per day. It's an open platform with over 1,200 Splunk apps available and allows for custom development. Splunk software can help organizations gain operational visibility across infrastructure tiers and dramatically reduce mean time to investigate and mean time to resolution to keep critical services running. In this demo, you'll see how Splunk and Cisco UCS products enable the three phases of operational intelligence: the monitor phase, gain insight and visibility of system health and capacity across your infrastructure; the detect phase, quickly detect, troubleshoot, and resolve issues in your environment across the entire application stack; the prevent phase, use operational analytics such as trends of most common issues, resources most impacted by recurring problems, resolution times, and available capacity. Having a complete view of your infrastructure performance and uptime status is critical to serving the business requirement and address any potential issues before they are reported by your customers. By collecting and aggregating performance data in Splunk Enterprise from key services in your application infrastructure, we can put together this dashboard, which shows us the key health metrics for each of our core service layer. The color icon of each metric indicates severity based on whether the value falls above a performance threshold. The ops team of the Alliance VR gaming website is monitoring a recent software update for the launch of a new game. The release was pushed into production and went live earlier in the morning that day. Around 10 a.m., a Splunk alert triggered an email notification directing ops to this infrastructure overview dashboard in Splunk. Right away, they can see red and orange indicators. Web requests are slow. There are many application errors. Database performance is slow, and the storage usage is in a warning state. The ops team starts investigating. They first check with the development team for any known scalability requirements that they may have missed. The development team asks for additional infrastructure resources to be added in production to handle the increased user load. To determine whether the development team's request for more servers will solve the problem, ops needs to check the status of the data center resources. They can drill down from here. This dashboard gives the ops team visibility across the server infrastructure deployed and managed by Cisco UCS. It shows data that has been collected efficiently in real time across all UCS managers using the Splunk add-on for Cisco UCS. This is an example of a dashboard that you can build based on the searches of the UCS data collected by the Splunk add-on. In Splunk, you can edit dashboards such as this one to customize look and feel, searches, and drill downs. Ops checks the load of the servers across the UCS manager to determine if any server is over or underutilized. Right away, it's clear that none of the systems are over 80% load, but we do see some that are within 20% range. So far, the ops team can confirm that we have enough server resources to handle the spike of gamers. This chart shows the system faults data collected from UCS manager. UCS provides very rich fault information with details about each fault, source node, severity, reasons, etc. As we can see it all here. Now that the ops team has found no major issues with their data center infrastructure, they can take a closer look at the other infrastructure layers. This ops dashboard helps investigate any unusual performance degradation that would potentially point to a root cause. Each chart shows the normal average for the corresponding type of performance data. We see slowness with the web requests. We also see a spike with the number of critical errors of the application around 10 a.m. The database query times increased as well. The storage capacity spiked as well. Let's drill down and check the status of the database. In this dashboard, we see first the top 10 slowest queries that are potentially slowing down the application. As we can see, these are suboptimal create and insert statements that are being executed across the database. The database performance charts overlaps two time series, the query response time and the DB concurrency queue. We observe a spike in the queue around 10 a.m., which also is higher than the expected normal concurrency. We also see an increase in query response time around the same time. By now, ops team has determined the type of queries that contributed to filling up the queue. The code is generating lots of create commands that are creating new DB tables for each game and associating that with every user, the insert statements. This explains the increase in used storage around the same time when the database performance became poor. Next, let's find out the web request and application code that's generating these type of SQL queries. In Splunk, you can correlate multiple events from separate data sources. Each row here is a correlation of events from the web server, the app server, and the database, starting around 10 a.m. The three events are correlated by user ID, which is the J session field, and user IP address, the client IP or the source IP field. By correlating these events, the ops team can quickly find the web requests and application modules that generated the slow queries and flooded the DB with connections. The ops team now has proof that a change in the recent application code caused suboptimal slow queries, hence slower web requests, too many DB concurrent queries and connections, hence application errors, increase in the DB used space caused by too many write queries. In this demo, we showed a way to find mean time to innocence, as we saw an application code change, not the server or the data center infrastructure. You now know how IT ops teams can use Splunk across infrastructure components including UCS to streamline troubleshoot of an incident, quickly find root cause, and isolate normal system loads.